Now it's time for the next presentation. Hopefully Emmanuel is here. I see him.
Hey, I'm here.
Hey Emmanuel, nice seeing you. And thanks for joining us, spending time to prepare and present today. Emmanuel is one of the active developers in the past years in the Kamailio project. A couple of modules written by him, if I remember, like NSQ was yours and QA JSON. And this one I actually was the reason I thought worth asking Emmanuel to give a presentation about how JSON can be used for a better scalability or distribution of present states across different SIP systems, correlated, of course, with some interest I have seen into the mailing list. And to add another set of things for testing my last development on presence for the in-memory presentative records. We all know that presence it's a little bit delicate in SIP, and testing requires many devices. Each device has its own tricks or its own approach sometimes. Not to make it longer, thank you, Emmanuel. I let you take the floor now, and looking forward to your presentation.
Thank you, Daniel, for the introduction. Let me share my screen. Okay, so I'm going to be talking about distributed presence with Kamailio and JSON. A little bit about me. My name is Emmanuel Schmidbauer. I'm a VoIP engineer at TextNow. I have about 10 years experience with SIP. I'm still learning. As Daniel mentioned, I'm a Kamailio developer. At TextNow, we have a really cool app that gives you a US or Canadian number, allows you to text or call for free. But we don't actually use presence at TextNow. So this presentation is based on work I did a few years back. What I'm going to talk about is basically some presence modules and distributed presence design. I'm not really going to get into the SIP specifics on how presence works or RFCs or anything like that. So what is presence? Typically, presence is like, in terms of the user experience, is the busy lamp field or BLF, message waiting indicator, or shared call appearance. There's probably more that I haven't used, so I might be missing those out. Shared call appearance is a bit trickier to implement in like a multi-tenant hosted PBX environment. So I'm not really going to touch on that. Basically my experience is with BLF and message waiting indicator. So why Kamailio presence in JSON? Well, it kind of came out of a scaling issue. We originally just had FreeSwitch doing all the presence and registrations. What we noticed though is around 800 users, FreeSwitch just couldn't keep up and it would basically freeze. So we needed a way to scale in like a hosted multi-tenant PBX environment. We were already publishing call events to a message queue using NSQ for our software. So we thought we could just tap into the call events message queue for presence. That would probably be the best solution. So we kind of went with NSQ. NSQ is a real-time distributed messaging platform. Basically, it's like any other message queue, like RabbitMQ. The only difference is there's no broker. So it's a little bit more resilient, in my opinion. So as I mentioned, sorry. Oops. So as I mentioned, we already had an NSQ cluster. We already had event callbacks hooked in the FreeSwitch ESL for publishing to our cluster. And we looked at what 2600 Hertz was doing with Kazoo. So I want to give a big shout out to them for kind of leading the way in these sorts of things. They're always kind of pioneering in the SIP world. So this diagram kind of shows what presence looked like before with just FreeSwitch, and then after with FreeSwitch and Kamailio. Leveraging Kamailio kind of allowed us to scale. We broke the bottleneck that FreeSwitch had presented, and it worked great for a long time. After some time, we wanted it to be more extensible and less of a black box. We didn't just want to just limit it to NSQ. So we moved some stuff into the already established JSON module, like the transformations. We extended the JSON module API, and I created a new module called Presence User Agent JSON, which basically takes JSON and injects it into the Presence module via the API. So this allowed us to shift the NSQ module to just a message consumer, and using the other modules, JSON, Presence User Agent JSON, and Presence modules, we could control presence. Now you can use other modules to publish presence, and I've done this with EV API, HXX, or HTTP, sorry. Also, if you haven't used EV API, it's super cool. I highly recommend checking that out. The CG Rates team developed a really cool EV API client in Go. So definitely check that out. So this kind of shows a diagram of before with just NSQ, and then after with extending to other modules. And you can see that you do not need to just use NSQ. You can use other modules to control presence. So now I'm going to talk kind of about scaling presence in more general terms. What I have here is an edge proxy, and I think that's pretty typical in like a hosted multi-tenant environment. And that the edge proxy kind of serves to remove some overhead for the other nodes in your SIP cluster by handling TLS and TCP connections, and then shifting it to UDP, perhaps on a private subnet. Use the dispatcher module to distribute traffic, and that adds some fault tolerance. If any node behind dispatcher fails, your cluster will still be operational. And we used DMQ userloc to share all the user location data. And you can operate completely in memory, no database backend this way, because if any nodes restarts, it's gonna automatically get up to date with the user location data from the other nodes. This also allowed us to skip authentication on the subscribe requests. Using the user location information, you can basically check if the user's registered to make sure they're authenticated for that subscribe. It's kind of, I think it's an improvement because at scale, skipping auth removes a lot of overhead. There is a little overhead added with DMQ, but I think it's worth the trade-off. So this diagram kind of shows scaling with NSQ. We're distributing the presence from call events in FreeSwitch. We have a Go app that binds to the call events, and it's basically publishing presence messages via NSQD. The presence servers there are just consuming the messages and updating the presence table. And when the user agent subscribes, a notify is sent out, lighting up the line key or not. As I mentioned, the SIP proxy is doing a lot of the lifting on the edge. It's doing server-side NAT handling, so the SIP presence servers don't have to worry about that. They don't have to worry about TCP connections either. And the subscribes are kind of distributed across all the presence nodes using dispatcher. So the SIP proxy role is pretty simple. Right here, it's just distributing the subscribe requests to the SIP's presence nodes. One thing I wanted to show here is the notify handling here. We're basically saying if the notify can't reach the user agent, send a reply of 408 to the SIP's presence server, and the SIP presence server automatically removes that subscriber from the active watchers table, and that helps with not sending. It stops sending notifies to agents that are no longer reachable, so that helps with scaling a lot. Because if you have a lot of like dead active watchers in the table, you're going to be sending notifies out to basically nobody. So I just wanted to illustrate that, and that's something that's built into the presence module, I found out. And here is the SIP presence role. Basically, it's taking a subscribe. It's checking if the user's registered. If they're not registered, it actually says to retry within 5 minutes, a random period within 5 minutes, because there is a possibility that a race condition can exist where a subscribe hits the presence server before the registration is saved to user location data and propagated to the SIP presence server. But this retry after header tells the user agent to retry within 5 minutes, and hopefully by then the user data is propagated to the SIP presence server. And the NSQ module here use an event route to basically just take the NSQ payload and publish it, which essentially sends the notify. FreeSwitch is pretty simple. It basically uses something called the presence ID channel variable, and this is completely custom, which is great because you don't have to use the SIP username and password. You can create custom presence line keys such as parking. It's really useful. What I'm basically showing you here is ESL connection and then binding to the channel call state. And then these are some of the event headers that are really useful for presence. So if you've got like an app that's binding to the event socket events and parsing the headers, this is probably what you want to use. And I'll show that how that can be propagated with Go. So here's Ghostruct that basically represents a presence record. Go is really good at marshaling data into just a JSON, and it's also has a great package for NSQ. So basically, you can see here I'm creating a presence record in Go. I'm marshaling it to byte data, and I'm publishing it to the NSQ topic here, which is Kamailio world. And then I've got Kamailio here, which is subscribing to the topic and a channel. And I won't really get into setting up an NSQ cluster. It's actually really easy. You can check the NSQ documentation for that. But you don't need to use NSQ. Here's an example of just using curl to publish presence events. And I've done this for load testing. It's actually pretty cool. You can make your phone light up pretty crazy with just doing a ton of curl requests. So it works, but does it scale? It scaled great. We had around 300,000 active watchers in a single cluster with 2 presence nodes. Eventually, disk IO got in our way, which actually surprised us. But when we started digging in, we figured out there's a limitation in the presence module where presence records could not run in memory. The active watchers can run in memory, but the presence records could not. And this meant reading and writing to the database each time a presence update was sent, which when you have 300,000 active watchers can mean a lot of presence records being written to the disk. But Daniel to the rescue, he recently released support for full in-memory mode, which is great. It was on my to-do list for a long time, but he beat me to it, and he probably did it way better than I could ever do it, and way faster. So yeah, as he mentioned earlier, I did help him test it because I think this is a huge win for presence in Kamailio. That's pretty much it. You can contact me at my email. I have a blog, and that's my LinkedIn. I'm probably under time here, but if anyone has questions. Hello.
Thank you very much for the presentation. It was awesome.
Thanks.
Very impressed with your presence work, of course, and very grateful for all the contributions that you've done to the project.
Thank you. Cool. I'm glad you guys all got that, because halfway through I wasn't sure if the streaming was working.
No, it is. Sorry?
It worked great, I think. Yes.
Yeah, it really, I thought looked good. Worked great. I'm trying to see if there's any questions on Matrix. I'm not seeing any. Let me check on YouTube.
Emmanuel, can you stop share screening, because I think we get your screen. Okay.
Sorry about that.
No problem. It's probably better this way. I want to add also my thanks for this presentation, and also that someone got to like 300K of active watchers. That's quite a huge number in my perspective for SIP presence in general. We all know that SIP simple, it's the headache in telephony or voice over IP when trying to implement this BLF and the presence services. Sorry, Fred, that I got over you. I wanted to get the screen sharing off. The other question?
No, I was just looking for any questions that might have been on YouTube. Just positive feedback. It was pretty awesome. Somebody's in the process of implementing this and benefited from your presentation. I loved that the 10 years still learning. It's probably my favorite part of the presentation.
Yeah, to add also that Fred supported the development of the in-memory presence, their representative, because practically when the initial presence was added to Kamailio like 2006, so it was OpenSCR actually, it was taken in consideration that presentity, it's about this XML documents, you know, for just saying online, offline, you put a lot of tags around and the document gets quite big. Back 2005, 6, maybe 7, we are still concerned about like memory usage and so on, and presence for now like the mainstream services. So it was always with the database and an indexing in the cache, like just keeping in the cache. Yes, there is a present document in the database, but then always query to the database. So that was the limitation. Emmanuel spoke about it. And yeah, this is actually a really great information. I think the community will benefit immensely from this one, because everyone, including myself, sometimes I'm struggling to find the right design on partitioning users, doing data replication, or all these kind of tricks for scalability and having like a proved concept could save us the time on deciding the way we should move forward on some deployments. Okay,
Well, thank you for having me present. I'm truly honored for the opportunity.
You are more than welcome. Actually, you did a lot of contributions, a very good contribution to Kamailio, and I mentioned it yesterday during the open discussion, or maybe it was after stopping the recording, but this online event gave the opportunity to bring the developers that maybe they were not able to travel at our events in the past to speak and show what they did. You are at Kamailio World actually, so you came to Berlin, but this like distributed online event makes it easier to put the spotlight on people that contribute to the project, and on this shorter format, we did want to focus on Kamailio only as a presentation, because it would be hard to select from all the other amazing projects out there in the VoIP space, Janus, FreeSwitch, Omer, Asterix, CG Raids. Practical bringing these guys, which are very useful projects for Integrate, will actually fill the entire agenda, in my opinion. So. Okay, so then it's time to move to the next one. Thank you, Emmanuel, and looking forward to future contribution around the project.